Hello students. Now we are going to discuss about conservation of linear momentum. In previous video we have studied that linear momentum is the quantity of motion that is possessed by a moving object, and mathematically it is given as the product of the mass and velocity of that object. So now we are going to study about what is conservation of linear momentum. So basically by using Newton's second and third laws of motion, we can get a very important and fundamental principle of physics. We call it a principle of physics, that is known as law of conservation of linear momentum. And this law states that when there is no external force acting on a system of number of particles, then the total linear momentum of the system remains conserved or remains constant. Means if there is no external force acting on a system, there is no change in the linear momentum of that system of particles. This is the law of conservation of linear momentum, and we get this law from Newton's second and third law of motion both. दोनों का रिजल्ट हमें यही मिलता है at the end. So this law of conservation of linear momentum, that is denoted by P, states that when no external force acts on a system of several interacting particles, then the total linear momentum of the system is conserved. And also the total linear momentum of the system is equal to the vector sum of linear momentum of individual particles present in that system. So total linear momentum of system is equal to vector sum of linear momenta of individual particles. As I said that this fact we derived from Newton's second and Newton's third law of motion. So now we are actually going to derive this fact from both laws one by one mathematically. So first of all we are doing the derivation of law of conservation of linear momentum using second law of motion. So second law of motion is the law of force that states that the rate of change of linear momentum is directly proportional to the force applied to that system, or we get F is equal to dp over dt from that second law of motion. So we consider, for this we are going to consider an isolated system. The reason for choosing isolated system is because this law of conservation is only valid if there is no external force. The condition is mentioned here, when there is no external force. So the system that we are taking should be isolated. So we consider an isolated system containing n number of particles, suppose the masses of these particles are m1, m2, m3 up to mn, and they are moving with velocities v1 vector, v2 vector, v3 vector up to vn vector respectively, and their individual momentum, we are going to represent their individual momenta by p1 vector, p2 vector, p3 vector up to pn vector. So if we talk about the total linear momentum of the system, total linear momentum of the system, then this will be equal to the sum of these vector sum of these individual momenta. So we can write total linear momentum of the system p vector is equal to vector sum of these p1 vector, p2 vector, p3 vector up to pn vector, right? We can write p vector as the vector sum of individual momenta of every particle. Now from second law of motion, from Newton's second law, we know that the force F vector is equal to the rate of change of momentum. The force acting on a system is equal to the rate of change of momentum, but the system that we consider is an isolated system. So for isolated system, this quantity F vector is 0. Since the system we consider is isolated, so there is no external force acting on that system, which means F vector is equal to 0, but we know that this F vector is equal to dp over dt. So we are going to equate these two values, and by equating we get dp vector over dt is equal to 0, and since the rate of change of linear momentum, dp vector over dt is the rate of change of linear momentum, is 0, which implies that the momentum is constant or remains same for the system, and this is the required value that we want to prove. So in the absence of any external force, means when F vector is equal to 0 or when the system is isolated, its momentum remains constant. That is what we want to prove, because this is the law of conservation of linear momentum. So here we get the law of conservation of linear momentum from Newton's second law of motion. Now we are going to find the same result using third law of motion. So third law of motion is the law of action and reaction, that states that for every action there is equal and opposite reaction, and for this we have to consider at least two bodies. So now to show this, to derive law of conservation of linear momentum using third law of motion, we are considering two bodies. Let capital A and capital B be the two bodies of masses m1 and m2 respectively, and they are moving with velocities u1 and u2. So A is of mass m1 and has velocity u1, and B is of mass m2 and has velocity u2, and we consider that the velocity of A is more than that of B. u1 is greater than u2. Then if I draw a diagram of it, so here is body A and then other is the body B. Both are moving like this, A and B, with velocity u1, u2, mass m1, m2, and if u1 is greater than u2, then after a certain time this body A will approach B and collide with it. Okay, so this is the situation we have before collision, and object A is approaching B because its velocity is more than that of B. So after certain time this A will collide with the body B. Then during this time, the situation is like this. Means after certain time, when the two bodies collide, then body A and body B, this is the situation when the two body collide. So this is during collision. Mass में कोई change नहीं होगा, mass will remain same, but when they collide, there are forces acting on these two bodies, FAB and FBA. So during the collision, when the two bodies collide, they exert force on each other such that FBA is the force exerted by body A on B. FBA is the force exerted by body A on B, and FAB is the force exerted by body B on A. This is जो सेकेंड नंबर पे हमने लिखा है, that body will exert force on this body जो हमने first letter लिखा है. So FAB means the force that is exerted by B on A, and FBA means the force that is exerted by A on B. Now in this situation of during the collision, Newton's third law के according, the forces FAB vector must be equal to and opposite to that of FBA. So during collision, FAB vector is equal to minus FBA vector. Now we have a new term here called impulse, that means the effect of force. Impulse is the effect of force that is acting for a very short duration of time. So impulse is an effect of force, and that force should be acting for a small duration of time. So in this case, during the collision, now this is a momentarily situation जब दोनों का collision हुआ होगा. So for that particular situation, impulse of force AB vector is equal to the impulse of force FBA vector. दोनों forces का जो impulse है, that is equal because the forces are equal and opposite and they are acting for the same duration of time, and that situation is momentarily. So impulse of FAB vector is equal to impulse of FBA vector, and this quantity impulse is actually equal to the change in momentum, and mathematically it has the value force into delta T. So now in our case, impulse of FAB vector means this FAB vector is acting on A. So impulse of FAB vector means change in momentum of body A, and impulse of FBA vector means change in momentum of B, and these two are equal. So change in momentum of A. Now change in momentum of A क्या होगा? After the collision, these two bodies start moving again with some different velocity like this. Suppose this is A and this is B, and now their velocities are not same because of the collision and the forces acting. They get some new velocities V1 and V2. This is the situation after collision. So their change in momentum is final momentum minus initial momentum. There is no change in mass m1 m2. So final momentum of A is m1 v1, although its initial momentum was m1 u1. So change in momentum is m1 v1 vector minus m1 u1 vector. This is for A. Similarly for B, it is m2 v2 vector minus m2 u2 vector, or in terms of the formula F delta T, we can also write it as FAB vector delta T is equal to minus FBA vector delta T, right? So abhi for this time we have m1 v1 vector minus m1 u1 vector is equal to m2 v2 vector minus m2 u2 vector. So now these quantities are equal and opposite to each other, and to show this opposite thing we have to put a negative sign, that impulse of FAB vector is equal to negative of impulse of FBA vector, because these forces are equal and opposite, so their impulse, their effect is also equal and opposite. Similarly, change in momentum of A is equal to the negative change in momentum of B. So again we have to write a negative sign here to show that the change is equal in magnitude but in opposite direction. So on rearranging these quantities, we get m1 v1 plus m2 v2 vector is equal to m1 u1 vector plus m2 u2 vector. Now this shows that total linear momentum after collision, this is the total linear momentum after collision, is equal to the total linear momentum before collision. So since total linear momentum after and before collision is same, so this proves the law of conservation of linear momentum, that is momentum remains constant. So this is total linear momentum after collision and total linear momentum before collision, and this shows that total linear momentum before and after collision remains same. That means this is the actually law of conservation of linear momentum. So we prove law of conservation of linear momentum using Newton's third law of motion. That's all for the video. For further videos, stay tuned and keep studying. Thank you.